Okay, here we go. We're on to lesson 3-3. Hope 3-2 went well for you. In 3.3, we're looking at solving equations by creating equivalent equations. That's your vocabulary for that, is equivalent equations. But an equivalent equations are ones in which the solution is the same. If they have the same solution, it's an equivalent equation. Now, this lesson we're going to go through some types of equations. We're going to be using the we're going to be using the addition and multiplication properties of equality to allow us to do this, but I want to show it to you visually as well. The first part is about solving with a balance, and how if you have a balanced equation where each side weighs the same, and if you then do the same things to both sides, you can reduce it down to a point where you can see what equals what. In every case, it remains balanced, but here at the end, that balanced equation now shows us that x is equal to 2 of these ounces, or 2 ounces. These are all equivalent expressions. The next part of this is going to be an activity in which we use the computer algebra system to solve for a problem. I'm also going to show you for this activity how this could be done by hand. So the CAS can do it. We can do the same thing using the addition and multiplication properties of equality and end up with the same type of solution. So if it asks you to do it with a CAS, that's fine. If you've got one, do it. If you don't have one, do it by hand. It's not an excuse to not do it. So you'll do it either one way or the other. Then, we'll come to this in a second. Our next part of this is the covering the ideas and applying the math, the usual stuff here. Get ready for the mastery quiz. If you have questions, bring it to me. So let's go ahead and we'll get started on solving with a balance through that one screen I just showed you. Hang on a second. Okay, this is at a website called Math Playground, all one word, mathplayground.com, and I've got a balance that we can look at. We're asked to model the equation 3x plus 4 equals 13. Well, first off, it's how many x's are there. We're going to stack some x's up here. That's 1, 2, 3. And I've got 4 ones. So 1, 2, 3, 4 ones. Then on the other side, I've got 13 ones. Okay, and we see it balanced at that point. So we've got 3x plus 4 is equal to 13. So our model is correct. Now let's solve the problem. We need to isolate the x tiles, and there are 4 1 tiles on the left. To remove the plus 1 tiles, place a minus 1 tile on top of each one. This creates 0 pairs and removes the tiles from the board. Do the same thing to the other side of the scale. If you can not make 0 pairs on the other side, just place the minus 1 tiles on the scale, then check your model. Okay, so what we want to do is get the x's all by themselves. We're going to use the addition property of equality by adding -1 to both sides of the equation. What we do to one side of the equation, we have to do to the other. So first I'm going to add, there's a -1 there. I'm going to put one over here, still balanced. I did the same thing to both sides. So that's 1 pair. Got another one. So we can see here that I've got 3x left because I've canceled out all the ones. All the plus ones are balanced by negative ones. I've put 4 over there. I've only got 2 on the right side, so I'm going to put 2 more in there so I can get to 4. And now I'm balanced, and it shows me that 3x, or 3 times x, is equal to 9 ones. And let's check this. Okay. Clever. All right, now we can check it. Yay! Okay, so now we've eliminated those. We got 3x and 9. And here we have the 3 times x, and it's saying to divide. But what we're going to do, what we actually are doing while we are dividing both sides by 3, we're using the multiplication property of equality, which says that if we multiply both sides by 1/3, 1 over 3, times both sides of the equation, we'll get a balanced equation. So we're going to divide this, and we've got it divvied up, and so I can remove the ones that are not in that. So I'm going to remove this one and this one, and then we'll remove the ones here. So I removed 2 of the x's from one side, and I'm removing 6 of the ones, and I'm now left with x equals 3. The value of x is 3, and just click on the next button to continue. So that's using a balance scale to model an equation in the form of some variable times a coefficient, some variable x times a coefficient 3 plus a constant is equal to, in this case, a constant. And that's modeling an equation with the scale. Hey, we've got another problem, but we're going to move on. You can come to this site on your own. Remember, this site is called mathplayground.com, and you can look up the interactive scale if you'd like to try to take a crack at that yourself. Okay, we're going to then move on to the CAS activity and modeling that in writing. Okay, we've got our CAS. We're going to take a look at how we can use that to model the steps to solve an equation. So the equation we've got in our activity was 8x minus 12 equals 4. So we're going to put in 8. Remember, we got to put in the multiplication symbol, so 8 times x minus 12, and that's equal to, remember to look for where the red has appeared. That's the button that's being pushed, and it's equal to 4. Got it right? 8 times x minus 12 equals 4. Yep, we'll hit enter. And so the next thing it says next enter plus 12 to instruct your CAS to add 12 to both sides of the equation. So before I do that, I wanted to just real quick take a look at this. If we're going to do this by hand, we've got, let's see, 8x times x minus 12 equals 4. Okay, so we've got that by hand. We've entered it in there. Now, for the CAS, it says next enter plus 12 to instruct your CAS to add 12 to both sides of the equation. So let's go ahead and do what it said. It said to enter plus 12. And you'll see that it shows you answer plus 12. And it doesn't really look like what it shows you in the book, but this is what we've got. So the answer is the answer for the previous one, which is 8 times x minus 12 equals 4. So that answer plus 12. We hit enter. Now it makes sense because it shows us what's happened. We had 8 times x minus 12 equals 4. That whole thing, we're going to add 12 to both sides of the equation. And we get that 8 times x equals 16. Let's take a look here in our handwritten one. So we had a minus 12. We're going to add 12 to both sides of the equation. So that means we're going to have 8x minus 12 plus 12 equals 4 plus 12. And minus 12 plus 12, these are opposites, right? I mean, we could say that this is plus a negative 12. Remember the algebraic definition of subtraction. So 8x plus a negative 12 plus 12. A negative 12 plus 12 is 0. And we get then that 8x equals 4 plus 12 is 16. So there's our work in writing. And here we use the addition property of equality, where we added the same thing to both sides of the equation. It remained equal. Remained equal. 8 times x equals 16. Our next step, it said to divide 8 and do that to both sides of the equation. So we'll just do what it says, which is divide by 8, and then we hit enter because that doesn't show us what we really want. Okay, there we go. 8 times x equals 16 divided by 8, and we get then that x is equal to 2. We've got our solution using the CAS. Let's go down a step. Let me go to the next page and we'll show you what that looks like. We're going to use the multiplication property of equality, and we're going to divide both sides by 8 or multiply both sides by 1 over 8, and we'll get the same result. So we're going to have 1/8 1 over 8 times 8x, and 8 over 8 is 8 divided by 8 is equal to 16 times 1 over 8, and 16 over 8 is 16 divided by 8. 8 over 8 is 1, leaves me with 1 times x, which is x. 8 goes into 16 2 times, x equals 2. I have a solution. So I did this both ways. If you're without a CAS and you're asked to do a problem and show how it's solved with a CAS, go ahead and do it by hand. Show the steps that are necessary to solve the problem without the CAS. With a CAS, go ahead and do your steps. Show me what results for each side, and we'll see what happens. I'm going to go through one more here for a CAS example, just to give you one more example to go through, and then I'll let you get going on the covering the ideas and applying the mathematics. Okay, we're back. We're going to go ahead and try an equation to see how it works, and there's in the tan boxes there's a step-by-step procedure for how to do this. And the first thing is solving a linear equation using a CAS. Well, here's our equation. This one is 4 divided by 7, and I need to put that in parentheses, times my variable z. The reason I put it in parentheses is if I didn't, what's going to happen is it's going to it would have been 4 over z, 7 times z. It would have done it in a linear way, and I want 4/7 z, not 4 over 7 z. So got my fraction, 4/7, put it in parentheses, times z. Next step is plus 2 divided by 3. That equals 1 divided by 7. Okay, so we've got this entered in here. We've got 4/4 times z plus 2/3 equals 1/7. And we want to solve this for z. So we go ahead and hit enter. And it's all in there. Looks good. And decide what operation to perform. So we got to figure out something here. And the clue to this is if you do something and it makes it harder or more complicated, you're probably heading the wrong direction. Maybe you should do something else. So you want to take a step back and try something else. So what are you going to do to this one? Now that we're at this point, you could look at it, decide, well, what has to happen here in order to get the kind of values that we want. So we could try to isolate the z's. That's what we did on the last one, which would mean we'd have to add the opposite of 2/3 to both sides of the equation. So let's do that. And adding the opposite is subtraction, so we're going to subtract. So minus 2 divided by 3 minus 2/3, enter. And so that helped a little bit. We get 4 times z over 7, which is the same as 4/7 times z. And we have now a negative 11/21. It went ahead and found a common denominator. The common denominator for 3 and 7 is 21. And it's subtracted 14/21 from 3/21. 3 from 14 is a negative 11. Or negative 14 from 3 is a negative 11. So that was our first part, and now we want to isolate the z. So in the previous example, we divided by 8. Well, that 1/8 was the reciprocal of 8. So 1/8 times 8 is equal to 1, and now we're asking the question, what's the reciprocal of 4/z? Well, the reciprocal is whatever number when multiplied times 4/7, sorry, I said 4/7, is going to equal 1. And that's going to be the inverse of this. The inverse of 4/7 is 7/4. And so we're going to multiply by 7 divided by 4. How about if I put a divided by 4? 7/4 is the inverse of 4/7. And we're going to do that to both sides of the equation. We hit our result. And so we get 7/4 times both sides of this. Z is now by itself. And I show that Z is equal to a negative 11/12. And I have a solution. So remember, as you're trying things with the CAS, give it a crack. If it doesn't seem to be making it simpler, then go back and try again. If you're doing it paper and pencil, the same rule applies. If it doesn't seem to be making it easier, then go back and try something else and see whether that will work for you. Well, good luck with this. If you have questions, again, please ask. Be glad to help you out wherever I can. Ask other people. There's folks around that know stuff. Good luck doing the covering the ideas and applying the math, and best of luck on your mastery quiz. See you soon.